here we have problems that require the use of the sum and difference formulas for sine and cosine. And you can see this group of formulas up here. These are the sum and difference formulas. And we'll just use whatever formula applies. We'll find some missing values, plug those values in here, and then just do the simple multiplication and addition or subtraction, and we'll have our answer. Let me show you how this works. In this first problem, it says the sine of alpha is 3/4 and alpha is between pi over 2 and pi. And the cosine of beta is -5/8, and beta is between pi and 3 pi over 2. And we want to find the value of the cosine of a plus b. So we're going to use this formula right here. Cosine of, well, it's alpha plus beta here, a plus b here, same thing. We're going to need both the cosine and the sine of a and b to fill out this formula. What we have is the sine of a and the cosine of b. So we've got to find some missing values. The way we do that is really simple enough. We're going to use our basic trig identity that the cosine squared of theta plus the sine squared of theta equals 1. And we're going to plug our value in here. So in this one we have 3/4. So 3/4 squared plus the cosine squared equals 1. Now we subtract that 3/4 squared, so we'd get cosine squared theta equals 1 minus, and let's do the squaring, 9/16. And that means cosine squared theta is, well, 1 minus 9/16 would be 7/16. And then you see we have to take the square root to get cosine. And we'll do that. So cosine of theta equals, well, positive or negative, square root of 7/4. But we need to check whether this is going to be positive or negative, and we have the answer to that. They've told us that this angle is between pi over 2 and pi. So let's look at between pi over 2, which is right here on the unit circle, and pi, and is the cosine positive or negative? Well, cosine is the x values, this is the second quadrant, so that's going to be negative. So our cosine is negative square root of 7/4. That's for cosine of alpha. I'm going to put that right up here. Cosine alpha negative square root of 7/4. Now we're going to do the same thing for the missing component over here. We need the sine of beta. Let me skip a few steps there, and we would square this, subtract it from 1. So the sine squared of beta would be 1 minus 25/64. And if we do the subtraction and we do the square root, we're going to get the sine of beta equals, let's see, that's going to be square root of 39/8. And once again, we have to ask, is that positive or negative? And we're between pi and 3 pi over 2. So here's pi, here's 3 pi over 2. We're in the third quadrant. Everything's negative there. So that's going to be a negative square root of 39/8. So the sine of beta is negative square root of 39/8. Now, all we have to do is plug these things into this formula. And what you can see is we need the cosine of both minus the sine of both for this one. So the cosine of a plus b is the cosine of both minus the sine of both. So let's take our cosines. We've got negative square root of 7/4 times, and our cosine here is negative 5/8. And that's going to be minus the sine of both multiplied together. So the sine of the first one is 3/4. And sine of beta we figured out to be negative square root of 39/8. And then let's go ahead and do our multiplication here. The negative times a negative is a positive. We're going to get 5 times the square root of 7/32 minus, well, actually plus, because negative times a negative again, 3 times the square root of 39/32. And if you wanted to crunch that out as a decimal in your calculator, you could certainly do that at this point. But I think bringing it to here is good enough for our purposes right now. Let's try one more of these just so we've got it down. Okay. So in this one, you can see we're trying to find the sine of alpha minus beta. So the formula we're going to use, let's bring that out here, is the sine of a times the cosine of b minus the cosine a sine of b. So let's write that down so we don't forget. So sine of alpha minus beta equals sine a cos b minus cos A sine B. All right, so we've got the right formula. Now we have to find our missing values and just plug them in. So let's go ahead and do that. Here, the sine of alpha is 3/8, and alpha is between pi over 2 and pi. So let's pi over 2 and pi. So our sine is positive, but our cosine is going to be negative. So cosine of alpha is a negative something. And what we're going to need to do is take 1 minus the square of 3/8. So that would be 1 minus 9/64, and then take the square root of that, right? So that is going to come out to be, let's see, 55. Yeah, so the cosine of alpha would be negative square root of 55 over 8. So I skipped a few steps there. Remember, the cosine squared of alpha would be 1 minus the sine squared of alpha. So if you're not sure, go back to that original identity, cosine squared plus sine squared equals 1. That's how I figured this out, starting with the sine there. Let's do the next one. The cosine of beta is 7/8, so the sine of beta is going to be, well, let's see, is it going to be positive or negative? So it's between negative pi over 2 and 0, so that would be down here. And the sine is going to be negative there, so that's another negative. And we're going to have 1 minus this thing squared, and then take the square root of it. So 1 minus 49/64, but take the square root of it. And let's see what that is. So I think we come up with negative 15, yeah, negative square root of 15 over 8 for the sine of beta. All right, we've got all our pieces now. Let's plug them in up here. So the sine of alpha is 3/8, and the cosine of beta is 7/8, minus the cosine of alpha, which is negative square root of 55 over 8, times the sine of beta, which is negative square root of 15 over 8. So on this side we have 21/64 minus, let's see, 55 times 15. I think you're going to get 825. Square root of 825 over 64. I think this can be simplified though. Let's see if we took a 25 out of there. Ah, yeah, that's 33/25. So this would simplify to 21/64 minus 5 times the square root of 33/64. And at this point we can leave it as is. That's a good enough answer. So that's a little bit of work with using the sum and difference formulas for sine and cosine.